Hello everyone. Good evening. So I think my voice is audible, right? Right. Yes, I think my voice is audible. Yes. So we'll start today's session. So far, what we are doing is we are discussing previous year solutions of UPSC Mathematics Optional Paper 1. Linear algebra already we have completed last 10 year solutions, and we have started calculus after linear algebra. In calculus, we have completed 24, 23, 22, and 21. So in this video, we will solve 2020 paper of calculus, right? That is mathematics optional paper 1 consisting of calculus part, right? Okay. So in this paper there are five questions. There are five questions and carries 75 marks. So all five questions are very standard questions and very simple questions also. So we'll directly get into problem number one. So problem number one is based on finding the limit of a function. So evaluate limit extending to pi by 4 tan x power tan 2x. So all these kinds of problem you can come across in my playlist itself, right? Content section of calculus. You can refer that also. So when I apply the limit, it is of the form 1 power infinity, right? So when I apply the limit, so tan pi by 4 is 1 and tan 2 into pi by 4 is tan pi by 2 and tan pi by 2 will tend to infinity. So when I apply the limit, it is of the form it tends to 1 power infinity, right? It tends to 1 power infinity. So again we know this kind of pattern or this kind of problem, right? That is limit extending to a f of x power g of x. So if we have function power function f of x power g of x, and when you apply the limit extending to a, suppose if this tends to 1 power infinity form, when you apply the limit, then the limit of this function, then the limit of this function is given by e power limit extending to a g of x into f of x minus 1. So very standard limits formula, standard formula of limits. When you apply the limit, if your function tends to 1 power infinity, then the limit of that function is given by L is given by e power limit extending to a g of x into f of x minus 1. So here this is our f of x and this is our g of x. So f of x is tan x, g of x is tan 2x. When you apply the limit, it tends to 1 power infinity form. So this limit of this function, this limit is same as this. Sorry. Okay. So this limit is same as e power. This limit is same as e power limit extending to a. So g of x. So g of x is tan 2x into f of x minus 1. So which is tan x minus 1. So we have e power limit extending to a. Uh, Here our a is pi by 4. So I will apply pi by 4 here. So we have limit extending to pi by 4. Tan 2x tan x minus 1. So this will be e power. So e power limit extending to pi by 4. We know tan 2x, right? So tan 2x is 2 tan x by 1 minus tan square x, right? 2 tan x by 1 minus tan square x. And this is tan x minus 1. See, always I recommend you to not to use L'Hopital rule, right? So when you apply L'Hopital rule, you need differentiations, right? You always go by standard formulas, right? That's what I would have said in my content section of calculus. So I'm not going to apply L'Hopital rule here, right? I'm just going to do by standard simplifications. So we have tan 2x is 2 tan x by 1 minus tan square x, and this will be, so our liquid limit is e power limit extending to pi by 4 2 tan x divided by, and this 1 minus tan square x I can write as 1 plus tan x into 1 minus tan x, and here we have tan x minus 1, so I'll take minus outside, I'll put minus 2 here, and I write this as 1 minus tan x. So 1 minus tan x, 1 minus tan x will get cancelled. So when I apply the limit, it is finite, right? So e power, when you apply the limit, we have minus 2 into tan pi by 4 is 1 divided by 1 plus tan pi by 4 is 1 again. So you will be left with e power minus 1. The required limit of the function is given by e power minus 1, right? Let L be the limit of that function, and the required limit is e power minus 1, right? Or 1 by e is your required limit. Okay, so very simple problem, carries 10 mark. So we'll move on to second question. Find all asymptotes to the curve 2x plus 3y is equal to x minus 1 whole square. So we need to find all asymptotes to this curve. So there are two types of asymptotes. One is parallel asymptotes. The other is oblique asymptotes. So parallel asymptotes, uh, it can be parallel to x-axis or it can parallel to y-axis. So oblique asymptotes means asymptote that is not parallel to x-axis or y-axis. So we will find all those asymptotes. To find parallel asymptote is very easy. Already we have discussed in tracing the curve, right? To get asymptotes parallel to x-axis, you equate the coefficient of highest power of x to be equal to 0, and to find asymptotes parallel to y-axis, you equate the coefficient of highest power of y to 0. You find that very easy to find asymptote parallel to x-axis and asymptotes parallel to y-axis. Now we will find all oblique asymptotes also here, right? You know what is asymptote, right? A line that touches the curve but it touches at infinity. Okay, so first what you'll do is, we will find all asymptotes. So first what we'll do is we will find all oblique asymptotes, right? So oblique asymptotes, asymptote that is not parallel to x-axis or y-axis. So first what we'll do is we will find all. First we will find all oblique asymptote. We will find all oblique asymptotes. Again, very simple. There is a method to find it. I'm not going to elaborate that method, but I'll just give you idea of how to find oblique asymptotes. So first what you have to do is you have to collect all uh, degree terms. So here I simplify that term. So we have 2x plus 3 times y is equal to x square minus 2x plus 1. So we have x square minus 2x plus 1, and then we have minus 2xy minus 3y is equal to 0. See here we have degree 2 term, degree 1 term, and constant terms here, right? So these two are degree 2 terms, so 1 1, right? These two are degree 2 term, and then these two are degree 1 term, and this is degree 0 term. So what you have to do is you have to collect degree. Here we have degree 2, degree 1, degree 0. You have to write all those, right? Suppose if I have degree 3, degree 2, degree 1, degree 0, you have to write all those. So I'm going to call that as P2 of x comma y. So P2 of x comma y means this is the highest degree, which is 2 in this equation. So what is that term? X square minus 2xy, right? So these two are degree 2 term. Then you collect all degree 1 term, so which is given by P1 of x comma y. So that is given by minus 2x minus 3y, and then you collect 0 degree terms, which is equal to 1. So first step in oblique asymptote is you have to collect all degree 2 term. You have to classify and then you collect separately. Suppose if you have degree 3, degree 2, degree 2, degree 3, 2, 1, you have to write in that manner. So here the highest degree is 2 only. So I'll write phi2, phi1 and phi0. Now what you have to do is you have to put x is equal to 1 to y is equal to m, right? So here in this equation you have to put x is equal to 1 and y is equal to m. See, we're going to find all oblique asymptotes, right? We're going to find all oblique asymptotes. So let us assume the asymptotes to be in this form. Y is equal to mx plus c, right? We're going to find all asymptotes. We need to find m and c, right? We need to find all m and all c. We need to find all m and you find corresponding c for that m. So our aim is to find m first. After finding m, we will find c for the corresponding m. Okay, here after finding all this, you have to put x is equal to 1 and y is equal to m. So I have phi2 of m. So we have phi2 of m. So phi2 of m, phi1 of m, and phi naught of m, right? And then phi naught of m. So phi2 of m will be, so here see, here x is equal to 1, y is equal to m. Then that phi2 will become a function of m. So I'm writing only phi2 of m. So if I put x is equal to 1 and y is equal to m, so we will have 1 minus 2m, right? X is equal to 1, y is equal to m. And here x is equal to 1 minus 2 minus 3m, and this is 1. Now you have to equate the highest degree term. Here phi2 is the highest degree term. You have to equate that to 0. That will give you all possible value of m, right? To find m, you have to equate the highest degree term, that is phi3 or phi4, whatever highest is. Here highest is phi2. You equate that to 0. So you will have m. Here there is only 1 m. Suppose if this phi2 is quadratic, you will get 2m. If it is cubic, you find all real values of m, right? So what you have to do is, now we have to equate, now we will equate phi2 of m to be equal to 0. Now phi2 of m is equal to 0. Why I am equating phi2? Because highest degree is phi2. Highest degree is phi2. So this will give you the value of m, right? So this will give you m is equal to 1 by 2. And this will give you m is equal to 1 by 2. So there is only one m. So for that m, you find the corresponding value of c, right? Suppose if this v2 is cubic, you find all real values of m. You can get 3 m's also. So for each m, you have to find c. So how to find c? Again, there is a formula to find the value of c. That formula c, to find the c value, it is based on nature of the roots of m. If all the roots of m are distinct, you will have one value of c. If the roots of m are equal, some roots are equal, you will have one value for c. I repeat, based on the roots of m. Here there is only one root which is distinct, right? Suppose, let us say you have a cubic polynomial here, phi2 of m. When you are solving, let us say your roots are 2, 2 and 4. So 2, 2 and 4. So two roots are equal. If two roots are equal, that is if some roots are equal, then you have one value, one formula for c. If all roots are distinct, you have one formula for c. I'll write down the two formulas for you. So that it will be easy for you when we'll do next similar problems, right? Okay. So I'll write down the formula here. Just a minute. Yes. If all roots of m are to find c, note. So to find c, uh, if all roots of uh, Pn of m, let us say this Pn of m, this n is the highest degree term. If all roots of Pn of m are distinct, then the c value is given by, minus Pn minus 1 of m divided by Pn dash of m, right? If all roots are distinct, there is a value for c, and if some roots are equal in phi n of m, right? Then that c value is given by c square by 2 factorial pn double dash of m plus c times pn minus 1 dash of m plus p n minus 1 of m equal to 0. So you have to solve this equation to get the value of c, right? Okay, so this is the formula I have given you. Yes. So here you can see we have one value of m which is 1 by 2, and that value is only one value, so it has to be distinct. So the corresponding c value for this is given by, see, y is equal to mx plus c. So we know m is equal to 1 by 2. For m is equal to 1 by 2, we're going to find what is c. Suppose if I have a series of m, for series of m, you have to find corresponding c values. So we will find c value here. So c value is given by minus p n minus 1 of m minus Pn minus 1 of m divided by Pn dash of m, right? So here n is 2 here, right? Because n is the highest degree term, so which is given by n is equal to 2. So minus P1 of m divided by P2 dash of m. So minus P1 of m. So minus P1 of m. So it will be minus of minus 2 minus 3m whole divided by phi2 dash of m. So phi2 dash of m will be minus 2, right? Minus 2. Now you have to plug the m value. For m is equal to 1 by 2, I'm going to find the c value, right? If m is equal to 1 by 2, the corresponding c value is given by, so these two will get cancelled. So minus 2 minus 3 times 1 by 2 whole divided by 2. So minus 4 minus 3, minus 7 by 4, right? Minus 4, minus 3, minus 1. Yes. So therefore, the oblique asymptotes, only one oblique asymptote is here because we are getting one value of m. Suppose if there is two value of m, you substitute another value of m and find another corresponding c for that. The oblique asymptotes are given by y is equal to mx plus c and y is equal to 1 by 2x minus 7 by 4. This is one of the asymptote to the curve which is not parallel to x-axis or y-axis. And asymptotes asymptotes parallel to y-axis. That is, you have to equate the highest power of y to be coefficient to be equal to 0. So here y term, highest power of y is 1, right? So you have to equate that to 0. That is equating the coefficient equating the coefficient of highest power of y, highest power of y to be equal to 0, right? So here what is the highest power of y, which is 1. So I'm equating 2x plus 3 is equal to 0. That means x is equal to minus 3 by 2. So this is an asymptote that is parallel to y-axis, right? We have an asymptote that is parallel to y-axis. And for asymptote parallel to x-axis, there is no asymptote parallel to x-axis, right? Because you have to equate the highest power coefficient of x to 0. So here the highest power of x is 2, right? Yes. For that the coefficient is only 1. So we have to equate that to 0. 1 is equal to 0 is not possible. So no parallel asymptotes. Sorry, no asymptotes parallel to x-axis. No asymptotes parallel to x-axis. You have to equate highest power of x to be equal to 0, coefficient of highest power of x to be equal to 0. So here the coefficient of highest power of x is 1. The x square is the highest power of x. So that 2 is the highest power of x. If I equate that to 0, that is not possible. So we have one oblique asymptote and one asymptote parallel to y-axis, and there is no asymptote parallel to x-axis. This is all you have to do, right? Find all asymptotes of the curve. Yes, very simple question again. So evaluate integration of 0 to 1 tan inverse of 1 minus 1 by x dx, which is carries a 15 mark question. Again, very simple, definite integration question. So let us call the integral I to be equal to integration of 0 to 1 tan inverse of 1 minus 1 by x dx. Now I'm going to make use of King's rule. That is integration of a to b f of x dx is same as integration of a to b f of a plus b minus x dx. That is, if you replace x is equal to if you replace x is equal to a plus b minus x, the integration will be same. So here a is 0, b is 1. So you have to replace x by 1 minus x. The integral value is same. So the same integral I is now 0 to 1 tan inverse of 1 minus x dx. This is integration of 0 to 1 tan inverse of 1 minus x minus 1 divided by 1 minus x dx. So these two will get cancelled. So this is integration of 0 to 1 tan inverse of x by 1 minus x dx. Call this as integration 2 and call this as integral 1. So I'm going to add these two integral, very simple 12th standard level integral. So I'm going to add 1 and 2. So adding 1 and 2, so we have 2y is equal to integration of 0 to 1 tan inverse of x minus 1 by x plus tan inverse of x by 1 minus x dx. See, tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy, provided if the value of x into y is less than 1. Here x into y will be equal to what? X into y will be equal to what? It will be minus 1, right? It has to be less than, right? Xy is less than 1, then only you can apply that formula. But we know the other result. Which is uh, tan inverse of x plus tan inverse of, and this is, okay, this is x by x minus 1, right? I'm just taking minus common here. X by x minus 1. Okay. Okay. So here you can see tan inverse of x plus tan inverse of y. X into y is equal to 1, right? But we know the other results. We know that, again, this 12th standard level inverse trigonometric properties. We know that tan inverse of x plus tan inverse of 1 by x. This is to a reciprocal, right? This will be equal to pi by 2, pi by 2, pi by 2 if the value of x is greater than 0, if the value of x is greater than 0, and this is minus pi by 2 if the value of x is less than 0. Now, we see that for x belongs to 0 to 1. So, here our x belongs to 0 to 1. What about the value of x minus 1 by x? What about the value of x minus 1 by x? It will be less than 0, right? See, you are subtracting a quantity that is less than 1 from 1. So, this denominator is, sorry, numerator is always negative, and this is always positive because you are choosing x from 0 to 1. So, x minus 1 by x is always less than 0. So, tan inverse of x plus tan inverse of 1 by x, I ought to use this, right? If x is less than 0, then this full quantity will be less than, will be equal to minus pi by 2. So, we have 2y is equal to integration of 0 to 1 minus pi by 2 dx. So, we have 2y is equal to minus pi by 2. So, integration of dx is x, upper limit minus lower limit will give you 1 minus 0. So, we have I is equal to minus pi by 4. So, minus pi by 4 is the required integration value for this problem. So, now we'll move on to next one. So, find the extreme value of the function x square y square z square subject to this condition. So, again Lagrange's method of undetermined multiplier. So what you have to do is, this is your objective function. Our objective function is a function of x comma y comma lambda is given by object f plus lambda g, and this we need to, okay, this is a Lagrange's equation. This f is our objective function and g is our constraint function, right? So this is our objective function. So we need to maximize our f, which is x square plus y square plus z square, with respect to the function g. That function is given by 2x plus 3y plus 5z is equal to 30. So this is our Lagrange's function, capital F, that is given by f plus lambda g, objective function with respect to the constraint function. So we have to find lambda, and we have to find the critical point. Here it is a function of three variables, so critical point will be a tuple x comma y comma z. So first what we will have to do is, we will form our capital F. So capital F is f plus lambda g. So x square plus y square plus z square plus lambda times g. G is given by 2x plus 3y plus 5z minus 30. So we will find our critical points. So we know Lagrange's method. Dou f by dou x equal to 0. Dou f by dou x equal to 0. Dou f by dou y is equal to 0. Dou f by dou z is equal to 0. So dou f by dou x is 0. So 2x plus 2 lambda is equal to 0. 2y plus 3 lambda is equal to 0. 2z plus 5 lambda equal to 0, right? I'm just partially differentiating with respect to x, y, z. So this will give you x is equal to minus lambda. This will give you y is equal to minus 3 lambda by 2. This will give you z is equal to minus 5 lambda by 2. So we have found xyz in terms of lambda, and we know this, and this we need to maximize with respect to the equation 2x plus 3y plus 5z minus 30 is equal to 0. Now you substitute the x, y, z here, get the value of lambda. So 2 times x is minus lambda plus 3 times y is minus 3 lambda by 2 plus 5 times z is minus 5 lambda by 2 minus 30 equal to 0. We'll multiply 2 here. So we will have minus 4 lambda minus 9 lambda minus 25 lambda whole divided by 2 is equal to 30. So this will give you minus 38 lambda. Minus 38 lambda is equal to 60. So lambda is equal to I'm equating this to 0. So we'll have lambda is equal to minus 60 by 38. So this will give you 30 by, so minus 30 by 19 is the value of lambda, right? The value of lambda is given by minus 30 by 19, and for that value of lambda, you find the critical point x comma y comma z. We can easily find that because x comma y comma z is in terms of what? Lambda only, right? That x comma y comma z is in terms of lambda only, so you can find that. Okay. So lambda is minus 30 by 19. So critical points are given by x comma y comma z. So x is minus lambda, y is minus 3 lambda by 2, z is minus 5 lambda by 2. So we know lambda is minus 30 by 19. 30 by 19. 30 by 19. So minus minus I'm just cancelling. So you'll have 30 by 19. This is 45 by 19 and 75 by 19. This is the critical point, right? So we have only one critical point. So at this point only extremum occurs. See, extremum, we are asking only extremum. We don't know this point gives maximum or minimum, that we don't know. But this point give you extremum value. Extremum point means it can be maximum or minimum also, right? So the extreme value is given by we need to maximize that function only, right? U x square plus y square plus z square. So this xyz, when this takes when xyz takes this value, it will attain extremum, but I don't know its maximum or minimum. So x square, y square, z square. I think you can calculate this, right? So if you calculate, you will get the answer as, I'll directly give the answer. You'll get the answer as 450 by 19. You have to substitute this point here. That's it, right? You have to substitute that point here. You just simplify, you'll get the answer. So we'll move on to the next problem. Yes, so we'll move on to the last problem of a 2020 paper. See, suppose I give you additional facts also. Um, they ask you to find extremum value. So this value is the extremum value, right? Suppose if you want to know whether this point is maxima or minima, how to do? Very simple, right? See, we need to maximize our function u, that is x square plus y square plus z square, with respect to the constraint 2x plus 3y plus 5z is equal to 30. Yes or no? 2x plus 3y plus yz is equal to 30. So we have a function of three variables. So we'll transform to a function of two variable. Um, you know how to find maximum minimum for function of two variable, right? This z is given by 30 minus 2x minus 3y divided by 5, right? So we have our u, which is a function of two variable, x square plus y square plus z square. So 1 by 25, 30 minus 2x minus 3y whole square. Now you have to check whether at this point whether it is maxima or minima. So that means we know a is fxx, b is fxy, C is fyy. Now if a is greater than 0 and ac minus b square is greater than 0 at the point x comma y, that means what? It is minimum if a is less than 0 and ac minus b square is greater than 0 at the point x comma y, it is maximum, right? It is maximum. This already know. This is nothing but a function of two variable, right? This is a function of two variable. You know how to solve, right? You know how to solve. Suppose if they ask you find the maxima, or if they ask you find a minima, means you have to do this. But here they are only asking the extremum value, so you can do at this itself. Okay. For this problem, you will get that point to be a minimum value. For this problem, you will get the minimum that value to be a minimum value. Okay. For this problem, you just find all these for this function, right? Let us call this as f. So you find second derivative y fxy. You substitute this x comma y here. You will get this point to be minimum value. This 450 by 90 will turn out to be the minimum value. Okay. This is not required, right? They're asking only the extremum value. The extreme value is 450 by 19, but I don't know whether that is maximum or minima. Suppose if you want to know maximum or minima, you convert that to two variable and you do the procedure. This you will get the minimum. You will get minimum value. Okay. Consider the function f of x. Find all critical points. Okay. Again, very simple problem. You know Newton-Leibniz formula, right? The previous 2021 solution we had discussed about Newton-Leibniz formula, how to differentiate a function under integral sign, right? You already know that formula, right? So Newton-Leibniz, what Newton-Leibniz formula says, d by dx of integration of u of x to v of x function of t dt, right? How to differentiate a function that is in the integral sign. Inside we have function of t dt, limit are functions of x. So this is given by f of upper limit. I already discussed in the previous video, dv by dx minus f of lower limit into du by dx. This is what Newton limits formula is. So here we have this as a function of t, right? You see this as a function of t. So I'm going to differentiate both sides, right? I'm going to differentiate both sides. I'm going to differentiate both sides. So we have f dash of x to be equal to d by dx of integration of 0 to x t square minus 5t plus 4, and then we have t square minus 5t plus 6 dt. So here we have this as function of t. I'm just applying this formula. So f of upper limit. So f of t will be f of x. So f of x. So f of x is x square minus 5x plus 4, x square minus 5x plus 6 into d by dx of upper limit minus f of u of x, that is f of 0. F of 0 is 0 into d by dx of 0. So everything will be 0. So we have a derivative function, right? So we have our function f dash of x. So f dash of x is x square minus 5x plus 4, x square minus 5x plus 6. So the roots of f dash of x will give you the critical points of f of x, right? The roots of f dash of x will give you the critical points of our function f of x. So we will factorize this. This x minus, sorry, this x, this is x minus 1, x minus 2, right? This square, no, x minus 1, x minus 4, this is, and this is x minus 2, x minus 3, right? So factorization of x square minus 5x plus 4 is x square. Just use factorization, right? X square minus x, yes, it is x square minus x minus 1, x minus 4. This is our f dash of x. Now what we'll do is, we can find the first subdivision. The first subdivision is critical points of f of x. So critical points of f of x. So you equate f dash of x to be equal to 0. So you will have x is equal to 1, 2, 3, 4 are the critical points, right? 1, 2, 3, 4 are the critical points. Now we have to find all points of local maxima or local minima. So you have to differentiate the other second derivative. You have to find f double dash. You substitute all the point in f double dash. If f double dash is greater than 0, it is minimum at that point. If f double dash at that point is less than 0, then it attains maximum at that point, right? So further you have to find f double dash, right? Or else you can simplify this, right? You form a fourth degree equation from this: x power 4 minus 5x cube plus 6x square, and then you just multiply these three terms with these three terms. You will get a fourth degree polynomial. You have f dash of x as fourth degree polynomial. You differentiate that, you get a cubic polynomial. You substitute all the points, critical points. You see whether it is greater than 0 or less than 0 at that point. Or you are, that is, finding second derivative and substituting the points of critical points. That is second derivative test, right? That is higher order derivative test. You can use first derivative test. That is, you can use the idea of increasing decreasing function to find maximum minima also, right? See, one method is finding f double dash and then substituting all the points there, that you know. I'll do some other way. That is, I'll see where the function is increasing, decreasing, right? Where the function is, I'm going to check where the function f of x is increasing and decreasing. So we know f dash of x is greater than 0 means our x is, for what x, f dash of x greater than 0, f is increasing. For what x, f dash of x is less than 0, are those points your f is decreasing. So we will check where this function is increasing, decreasing. So we know the critical points. The critical points are given by minus infinity, plus infinity, 1, 2, 3, and 4. So we have f dash of x to be x minus 1, x minus 2, x minus 3, x minus 4. So you take a random value and then you substitute. You see, you take 5 here. If I take 5, 5 minus 1 positive, 5 minus 2 positive, everything is positive here. That means our f is increasing in this interval, right? In between 3 to 4. So you take 3.5. So 3.5 minus 1 positive, 3.5 minus 2 positive, 3.5 minus 3 positive, 3.4, 3.5 minus negative. This is negative. From 2 to 3, you take 2.5, positive, positive, negative, negative. So overall it will be positive. You can take any number. If you take 1.5, negative, positive, negative, negative, negative. So overall it will be negative. If I take 0 here, it is positive. Now you can see our function is increasing here, decreasing here. When your function is here, you can see f dash of x changing sign from increasing to decreasing, increasing and then decreasing, increasing and then decreasing. That means if your function changes from increasing to decreasing, at that point it will have local maxima. Yes or no? Increasing to decreasing, increasing to decreasing. That means that point is local maxima. Local maximum, decreasing to increasing. Decreasing to increasing will give you local minima. Yes or no? Function is increasing and then decreasing. This will give you local maxima. Decreasing and then increasing. This will give you local minima. Right? So increasing to decreasing. This point is local maxima. This point is local maximum. Increasing to decreasing. Again, this point is local maximum. Decreasing to increasing. So this point is local minimum, and this point is again local minimum. Or else you can use secondary test also, but this will give you time consuming, right? See, our aim is to find which at which point it is maximum minima, right? So minimum low for second subdivision answers, third subdivision answer. You can quickly do this. Uh, Points of which local minimum occurs. Local minimum x is equal to 2 and 4. I don't know output value. They haven't asked what is the maximum, what is the minimum value. They are asking only the point of minimum and point of maximum. Local maximum at x is equal to 1 and 3. So at 1 and 3 it attains maximum, and 2 and 4 it attains minimum, right? Uh, this is very convincing, right? Instead of you have to find second derivative, substitute all those points, it will take time, right? Okay. Now you have to we have completed these three parts. Find the number of zeros of the function f of x in the interval 0 to 5. Again, this is time consuming. So what you have to do is you have to find all zeros of the function f of x. You have to find all zeros of the function f of x in the interval 0 to 5. Right? In the interval 0 to 5. In the interval 0 to 5. We already know the critical points are 1, 2, and 3 and 4. 1, 2, 3, and 4. But we don't know what is the output for 1, 2, 3, 4. Right? At 1 it has local max, at 2 it has local minimum. Now for problem point of view, you have to find that maximum minimum value, then only you can plot the graph, right? How to find, see, we know only f dash of x, but we don't know what is f of x, right? We know f dash of x. So this f dash of x will be a you will have f dash of x to be some fourth degree polynomial, right? Ax power 4 plus bx cube plus cx square plus dx plus e. So when you multiply this, you will have fourth degree polynomial. You integrate to get f of x. You integrate to get f of x. Right? You don't need to put constants. You just integrate this to get the value of f of x. Right? You just integrate this. So when you integrate, you will have a fifth degree polynomial here. Right? If you integrate, your f of x is a fifth degree polynomial. Right? See, a, b, c, d, e are some coefficients that you will have when simplifying. So in the fifth degree polynomial, if you plug these four values, you will get the output values, right? Okay, but I'm not going to do that, right? You are going to do. So f of 0 is obviously 0, because when you put x is equal to 0, the limit will be from 0 to 0. So interval will be 0, and we know, see, the function is increasing from minus infinity to 1. So obviously it will be increasing from 0 to 1. So 0 to 1, the function is increasing. At 1, we have a critical point. So the slope will be equal to 0 at 1. And then from 1 to 2, the function is decreasing. So the curve has to come down, right? And 2, again, it has a slope 0. So at 1, we have a slope 0. At 2, we have a slope 0. It is decreasing. The thing is, if it is, see, it can come like this also. Like this also, it can come. It can cut the x-axis also. That's why I'm saying you to find the value of f of 2, f of 1. F of 2 will be here, right? That's why I'm not moving below, right? And then from 2 to 3, the function is increasing. And at 3, we have the critical point. And from 3 to 4, function is decreasing. And 4, we have a critical point. And after 4, the function is increasing. So the value will go like this, right? How I know these points? These points you have to do just for you don't need exact value, right? You don't need exact value. Just you see whether that is positive or negative, right? Okay. Now you can see f of x has only 1 0, right? F of x has only 1 0. It is 0. At 0 it has 0. 1 0 in the interval 0 to 5. Right. So again, very simple problem. So that's it. So we have completed all 5 problems of 2020 paper. Uh, Very simple. All 5 questions are very simple, standard problems. So in the next video, we will solve 2019 paper. Right. So thank you. All the best.